Welcome to part 2 of our Intro to Proofs lecture, if you want to call it that. I don't know. I'm coming to you from room 252, the Circle Classroom, where I have a document camera. It's going to let me do things a little bit easier, I think. So we're going to go through, what I'm going to go through in this video is the last progress check that we rushed through in class last time. And then I'm going to go through section 1.2, constructing a no-show table, and then constructing a proof from that no-show table. Okay, so first, we talked about in the last section, on section 1.1, we talked about the integers being closed under addition, subtraction, and multiplication. So we might ask some other questions. Are the rational numbers closed under addition? Well, the answer is yes. And to explain that, you might pick two arbitrary rational numbers. So what is a rational number? A rational number is an integer divided by another integer, as long as b is not 0. And then another arbitrary rational number might be c divided by d, as long as d is not equal to 0. And so then I got to add these two arbitrary fractions. Well, what do you do in order to add two arbitrary fractions? I don't have the same denominator, so put on your algebra hats. What do we need to do? Common denominator. So this equals AD divided by BD. So multiply the first fraction by D over D, and the second fraction by A over A. No, B over B. And then equals AD plus CB over BD. Now, this thing right here, is that a rational number? Well, what is a rational number? A rational number is an integer divided by an integer. So is the numerator, the top number, an integer? Well, yes, because the integers are closed under addition and multiplication. So if I have 4 integers and I add them and multiply them, I still have an integer. If I take 2 integers and multiply them, I still have an integer. So this is an integer divided by an integer. And the last thing you'd have to check is this integer 0? Because you're not allowed to divide it by 0. But neither b nor d is 0, so b times d will not be 0. So that's why the rational numbers are closed under addition. Are the integers closed under division? The answer is, so this, I'll put a big yes here. The answer is no. And explained. So it's kind of a global claim, so I just need a counterexample. And 1 over 2 is not an integer. Okay, well, is a set of rational numbers closed under subtraction? Explain. Yeah, and you do the same thing as above, just with the minus sign. So you got your A over B minus your C over D, and that equals AD over BD minus CB over BD equals AD minus CB all over BD. And all these 4 letters are integers, and I'm multiplying and subtracting. Integers are closed under multiplication and subtraction, and they're closed under multiplication. So the top, the numerator, is an integer, and the bottom is an integer, and it's a non-zero integer, so rational number. All right? So those are not really proofs, but that's just a rough explanation. But it's really, I sometimes call it the sort of algebra I just did, the heart of the proof. So to make these proofs, you just have to have the right writing around them, and they become a proof. All right, moving on. Oh, I've got a problem with bleeding through the paper. So actually, I will pause now and create a new video once I print out a new piece of paper. So bear with me.